So now that we've been introduced to mechanical advantage, I wanted to look at each of the simple machines and their individual nuances. And let's begin with what I consider the simplest of the simple machines, the inclined plane. But before we begin looking at an actual example calculating mechanical advantage of an incline, let's do a quick review where you match these terms that we need to know to their definitions. Now, we've already seen these terms, so test yourself real quick. Go ahead and pause this video and try it on your own. Now, hopefully that wasn't too hard. Hopefully this was pretty simple, but let's go ahead and check your work. So let's start with A, the distance you apply your effort force on a machine. Let's look at that. It is a distance that you apply your effort force. Now, at first glance, you might look at effort force and think, oh, that's a force. So we got to look at our forces. But no, it is a distance of your effort force. So the distance of your effort, that is your DE, your distance effort A. B says the effort force you apply to a machine. So this is similar, but it is not a distance. It is the effort force. So that is right next to it, FE, effort force, or force effort, I should say. This is B. C says the actual advantage you get from a machine based on forces. Well, there's two key giveaways here. We know forces, so we can look at our AMA-free statement for F and AMA-free, or you could say actual mechanical advantage or actual advantage. That's AMA, that's C. D says the resistance force, usually weight, you are trying to overcome with your machine. So the key words here are resistance, force, or force resistance. That is FR. So this is D. And E says the distance you are trying to make your resistance force travel. So it is a distance, and we are talking about the resistance. So that is going to be distance resistance E. And then, of course, F, all we have left is IMA. Let's see if that's correct. The advantage we hope to get from a machine in an ideal world. So an ideal advantage or the ideal mechanical advantage. Yes, this is F. And real quick, let's draw ourselves out an inclined plane. And let's look at where each one of these terms belong in that inclined plane. So let's draw ourselves a little ramp here with some height. And let's label that height. The height that we are trying to, actually before we label that, let's draw a box. We want to push this box so we can visualize it. This is why I consider the inclined plane the simplest of the machines. It's the easiest to visualize. So we have some person, he wants to use this inclined plane to push some weight up a height here. And the height we want to push it up, that is the distance resistance. Whereas the length of the ramp, the length that we apply our effort force, that will be our distance effort. And so what do I mean when I say the length we apply our effort force? Well, the effort force is the force I am pushing on the box. That is FE. Whereas the force resistance, which we said was D, right here, force resistance, that is usually our weight, and in this case that is still true. Our force resistance is our weight going down, and we could even say that it is the weight here, and it doesn't look too good. Let's see if we can rewrite it a little bit better so we can read it. That's not too bad. Hopefully you can read that. This is force resistance, otherwise known as weight. And so this is where you can expect to see each one of your individual terms. And you might say, okay, well, that only covers your forces and your distances. What about your AMA and your IMA? Well, the IMA, we can say, is our IMA equation, which actually uses the two distances here to solve. It's IMA dr, you might recall, our silly little way to memorize our equation. IMA equals DE over dr, or IMA dr. And then we have our AMA, which is based on our forces, okay? And we can say AMA is free, AMA free, equals FR over FE. And it's very important to note that your AMA is based on forces. So you use your forces to calculate your AMA, or if you have forces, you calculate your AMA. Whereas if you're given distances, then you calculate your IMA. And the way you can remember that is look at the IMA dr. IMA is based on D, or distance, and AMA free, AMA is based on F, forces. And we've looked at inclined plane examples before in our previous videos, but let's go ahead, let's define what an inclined plane actually is, just so we have it for our notes. And all an inclined plane is an angled surface that lowers the force to move something up and down. An angled surface that lowers the effort force, or just the force, to move something up and down. Up and down. And then let's draw ourselves an example of an inclined plane and see if we can solve for the mechanical advantage. So we'll give it some height and some length. And let's say we know the distances. Let's say the height is 2 feet. And let's say the length of this ramp is 5 feet. And let's say our job is to push some box up this ramp here, but we don't know anything about it. We don't know how heavy the box is, and we don't know the effort force it'll take. Well, actually, let's use our consistent colors here. But we don't know what this effort force is. We don't know what the actual weight of the box is. But we do know our distances. And so the question is, what is the mechanical advantage? Well, you might notice we are given 2 distances, and we look, okay, what do we use to calculate our distances? Well, that is the IMA. The IMA-DIR equation is based on our D distances. So we'd say to solve for this, we would use our IMA equation, IMA-DIR. IMA equals DE over DR. And if we look, we know what these numbers are. We know our distance effort is the length of the incline, which in this case is 5 feet. So we'll say equals 5 feet on top, and then we'll divide that by our distance resistance here that goes on bottom. And we know our distance resistance is the actual height of the incline, which is in this case 2 feet. And if you notice, feet cancel out, so we don't have any units for mechanical advantage. That's kind of how mechanical advantage works. It doesn't have units because it's a ratio, so we can just say 5 over 2. Well, that is 2.5. And you could also say 2.5 over 1 because it is, or for that matter, you could say 5 over 2, but you could also say it's a 2.5 to 1 ratio. But there's no real reason to write all that as long as you understand that it's a ratio, so it has no units. All you need to know is that the answer is a mechanical advantage of 2.5 in this inclined plane.